Hello everyone, this is R. Suresh Kumar, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in the previous lecture, where I discussed about the different type of the spillways, how the spillways, feasibility of the spillways, why we have to provide the spillways, and also what the use of spillways discussed in the previous lectures. Now, there is a very important matter of the Ogee Spillway. So let us before actually what is meant by spillway. A spillway is one of the most important structure can be provided in the hydraulic structure like the dams and reservoirs, and can be component part. It can be very useful and excavated from the flood waves, and also it can be reservoirs from the downstream side. Safely the water can be sent to the reservoir in the downstream side without any damaging of the structure. So normally this can be composed major components, the approach facilities and the discharge conduit. There are the two types of the facilities is there, excavating of the spillways. So the outlet structure of the spillway of the tailwater, which is also energy dissipators. Energy dissipators, nothing but this can be provided as of any of the dams. The water can be flows here and it can be a hydraulic jump. The energy dissipator can be provided here, just like the tank. The water can be comes and it cannot be damaged the structures, and also it can be reduce the velocity in the upstream side. So this spillway can be next to the spillway design flats. Spillway design flats can be selected using some prescribed guidelines and the risk based of the analysis. Risk based analysis can be discussed. Next. Types of spillway. Let us straight drop spillway. Let us have to be overlooked from the one or two whatever have to be discussed in the previous. Straight drop spillway and overflow spillway and chute spillway and side channel spillway and side shaft spillways and siphon spillway and labyrinth spillway and buffalo chute spillway and cascade spillways and selection type on bottom left of the sluice ways. These are some of the types of the sluice. This is already important, we will discuss in the previous lecture. Now, very important, we have to go for Ogee Spillway. What is meant by Ogee? Why it is important? Ogee Spillway is the spillway can be provided maximum possible hydraulic structures and efficiency of the structural stability can be maintained by using the provided and is also economy. Avoid the formation of the objectionable and atmospheric pressure of the surface. The Ogee is the shape. What is meant by Ogee shape? It is the shape can be provided here like that. So this is the type shape we call as the Ogee type of the spillways can be provided. So this type is safely can be removed from upstream to downstream of the water flow from the reservoir. This can be shape is no negative pressure can be developed due to providing. If it is the providing the sharp edges, this is a different way of the flowing of the pressure. But here is a safely the water can be from the upstream side and also can be, from this structure it can be safely withdrawal from the downstream side. From this shape, no negative pressure can develop. The spillway can be designed heads. Here. This is the best example for the, let us see the Ogee spillway. So this type of this spillway we have to provide it, we call as the Ogee type. So that's why we call it as the shape it is provided as Ogee type. That's why we call it as a Ogee type spillway. So here as I told that these are the important of the structure, and also it can be safely the water stabilizing the structures of the hydraulic, and this shape is very downfall of the water from the upstream downstream safely can be taken. So that's the crest level. Let us see the component parts of this. This is the Ogee type spillway, and this is the crest level can be provided, and the maximum water MWL, the maximum water, and gates can be provided here. Gates can be provided to to allow the water in the during the floods. The excess water or surplus water can be removed by using the gates, and gates will be the control here. Next, non-overflow of the gates. Next, falling the water nappy. Nappy means that the water can be fall here from the upstream to downstream side. The falling is the falling of the water nappy. Next, traditional air wall can be provided. The hydraulic jump, as we know very well, the hydraulic jump. So, these energy dissipators can be provided here. So, energy dissipator can be provided to avoid the water discharges in the downstream side. Energy dissipators can be provided. So, this is the shape, and also this is the Ogee type of the spillway. That is the shape of the overflow. The head over the crest, as I told, the head over the crest. This is the head over the crest can be provided here, and the height of the spillway above the stream of the bed of the extra entrance channel, the inclination of the upstream place of the spillway. So here see, we have the different type of the shapes of the spillways. The first one is sharp crested weir. Here, sharp crested weir. This is the sharpness can be provided, and this is type one of the low heights can be provided as the weirs can be constructed. This is called the shape we call it generally weir, and this is the head. H can be provided here in the upstream of the sides. Next, design heads. Design heads is equal to H can be provided in the top of the heads of the design heads. Next, sharp crested weir. Next, this type of second we have to be Ogee spillway at the design of the flow. This is the Ogee type design of the flow. This is the head of the water above which is flowing in the above the spillway. That is we call as calculation. In the next we have to be there is formulas is calculating the discharge over the spillways. Here is that H is greater than design heads. Where H is greater than, here is H is equal. Here design head is equal to H. We have to provide it here like that. The shape will be like that. And again, the H, if H is greater than design head, what happens? It can be shapes will be provided here. The excavation of the turbulence will be provided in the bottom, and this can be separation. So the Ogee spillway with the greater flow. This type of the shape we have to be provided. That the Ogee spillway with the greater flow. And next one is the last one is the elements of the nappy in the sharp crested profiles. This is the how the shapes will be designed as per the design criteria of the purposes. How the it can be Ogee spillway can be provided. Here D is equal to D and R2 HC and Y R1, and this is 1.85 and 1. Of course, he has given some of the width of the A is equal to 0.175. This is the design criteria are given. Based on the design criteria, we have to be constructed while during the hydraulic structures. So that is the important. Next, V is equal to 0.2 V2 H and R2 is equal to 0.20 H. Then H is equal to design head. H is equal to design. Next, the elements of the nappy and shape of the crested of the profiles will be constructed. What is the design principle of the Ogee spillway? Very, very important of the design principle. Why we have to take the downstream of the spillway can be represented by the following equation, where x and y is the coordinates of the point and the spillway surfaces is the origin highest of the point O. O is the highest point. That is we have to see in the HD is the design head and including the head of the velocity, where K and N are the constant upon the inclination of the spillway. Xn is equal to K into HD whole to the power of HD into N minus 1 into Y. By applying this formula, you have to find the value. So here see that one. In this diagram, we can understand easily to the spillway design purposes. Here A is equal to have to take the A value and origin will be take it as separately, and the axis HD is equal to head over the spillway can be covered. This is the number MWL level, maximum water level can be provided, and height of the spillway. H is small h is equal to here provided as Ogee spillway height is equal to H and B is equal to width and can be provided, and the origin can be provided at the top, that is equal to X value and the origin x is equal to 1.85 is equal to 2 into ht whole to the power of 0.85d into y, and x to the power of n is equal to k into h into d n minus 1 into y, k into n minus 1 into y, where a is equal to a value 0.175 ht and r1 is equal to 0.5 ht and r2 is equal to 0.2 ht and b is equal to 0.282 ht. What is these values? This is the design criteria values can be consideration while designing of the Ogee spillway. So based on these equations we have to apply and calculation, and after the calculation we have to calculate the discharge calculations in the Ogee spillway. So let us see that one, where x and y value coordinates of the value. Let us see the x and y values. X is equal to here and y is equal to coordinates values will be taken into consideration, and the point of spillway, origin of the point that is equal to O, origin point, this is equal to O, origin point is equal to O, and again HD is equal to design heads, HG is equal to design head, this is one is the design head, and again the value of due to the k and n are the constant, and the k and n are the constant depends upon the inclination of the upstream of the spillway. So based on these values we have to be find, and also the calculation of the discharge, and also this can be used for designing of the Ogee spillway. So based on the consideration we have to let us design criteria on the upstream profile. Design criteria. What is the design criteria for upstream profile is equal to ensure that no discontinuity along the surface of the flow. The upstream profile should have the zero slope and the crest value the axis. And second, according to the latest analytical studies of the US Army, upstream side of the curve of the Ogee shape has been given the equation. By this is the research methodology. Research can be applied by using the US Army can be designed, and also giving the incorporate from the after the research they are to find out the some formulas. What are the formula? That is equal to y is equal to 0.724 into x plus 0.270 into h whole to the power of 1.85 by h to the power of 0.85 plus 0.126 into h minus 0.4315 h whole to the power of 0.375 into x plus 0.27 into h whole to the power of 0.625. What is this? Is the value of the formula. You have to find the y value. Find the y value. So here by applying this formula, the upstream side should be noted that upstream side of the curve should be neither made too sharp or too broad. That is a very important point you have to be remember here. And broad crusted supports of the lower nappy production falls to hydraulic pressure and reduces the discharges. If the curve is sharp, the nappy leave the Ogee profile causing the negative pressure and cavitation and increases of the discharges. High overflow of the spillway. If high overflow of the spillway, what we have to find? The overflow of the Ogee spillway are classified as high and low depends upon the ratio. How do you have to find? Height of the spillway of the crest from the riverbed. Height of the height of the spillway crest from the riverbed divided by design head. So it can be called as the low depends upon the ratio. So h is equal to head and the distance between the water and the crest level, as in the previous diagram we have to explain. HD is equal to design head, the value of the head. Let us see that the diagram you can understand easily. So this one is the HD is equal to, as I told. So B is equal to base width, A is equal to given the top width, and the design heads head due to the velocity is equal head due to the velocity approach HA is equal to, it is the velocity head given by HA is equal to VA square by 2G, that is equal to VA square by 2G. The total head you have to find the this is the equation according to the actual heads plus due to the velocity approaches. H is equal to H plus HA. If H is equal to HD,
HED is equal to HD plus HE. What are these formulas? These are the formulas are given by calculating the design head as well as velocity approaches, and the total head will be the calculated by using these formulas. Let us have to discharge calculation in the very important in the spillways. The discharge over spillway is composed based on the equations. Here Q is equal to CD into LE HE whole to the power of 3 by 2. Let us see the notations of this formula. So what is this one? Where Q is equal to, as we know that Q is equal to discharge in the Qmax. Where CD is the also quotient of discharge. If Q is equal to total discharge, CD is equal to coefficient of the discharge value. And again LE. LE is the effective length. We have to take it as LE. And where the actual effective head of the including head due to the velocity. Head due to the velocity is equal to HE. And approach that is equal to HE is equal to HD plus HEA. So HE is equal to, we have to find the HE value that is equal to HED plus HEA. So above this we have to be find out. By applying this formula, what we have to find? The total discharge at the Ogee of the spillway can be computed based on the equations. This equation you have to apply the calculating the discharge of the spillway. So hope you understand. Next, the effective length of the crest. The effective length of the crest of the overflow is spillway is given, and LE is equal to L dash into minus 2 into NKP plus KA into HE. Here that in this formula you have to find where LE is the effective length of the crest, LE is equal to net length of the crest, and HE is equal to actual total head of the overflow of the crest, where N is equal to number of the piers. Where N is equal to number of the piers. Kp is the pier contraction of the coefficient. Pier contraction of the coefficient. Where K is the abutment contraction of the coefficient. Abutment contraction of the coefficient. L is the effective length, and L is equal to net length. H is equal to actual total head, and N is equal to number of piers. Kp is the pier contraction, and K is equal to abutment contraction. Abutment contraction. So this is the, by using the by formula what we have to find, effective length can be find out. In the previous one we have to find the discharge over the Ogee spillway can be calculated by in the previous formula. So in this one you have to find the effective length of the crest can be calculated. So let us see types of the this is the broadly about the spillways. And based on this formula, you have to find out. And let us see the different type of the gates can be provided in the dams. So let us see the dam types of the spillway gates can be provided in the topmost. What are the gates? Flashboard or stop like the needles, and radial gates, and drum gates, and vertical lift gates, and bear trap gates, and rolling gates. So these are the gates can be provided in the spillway gates. So as we discussed about the what is the spillways and types of spillway, and the Ogee spillway, especially how the Ogee spillway can be calculated, design head, and the can be discharge can be calculated within. And now we have to be the types of different type of the gates can be provided. What are the gates can be provided in the topmost to surplus water can be stopped in during the storage of the water? Which type of the gates can be provided? Let us see that one by one. Stop leg gates. What is the stop leg gates? Stop leg gates are horizontal. So stop leg gates are horizontal. Wooden timber can be provided, which can be span of the between the groove of the piers. Construction of the crest of the spillways, and stop legs are punched down into the grooves from the top on the over the other, one over the other. This one over the other, it can be provided. So this can be in this groove we should have to provide the stop, and the grooves can be in this grooves we have to provide the wooden type of the stop can be provided. The locks will be raised to the after the operation it can be raised. It can be due to this one. The operation can be removed and water can be down first, and you want to store this one, you have to provide it up to this level and stop generally the small spillways. These type of the gates can be provided as the generally in the small type of the spillways. These gates are small spillways we have to provide it to stop the water, the stop legs. Next, needles. What are the types of needles? Needles are the wooden legs of the place inclined the position and tower head resting on the crest can their upper end supporting of the heads, and the needles some of the either remove the stop legs or can be difficult to the flow of the water. Needles are also used as small spillways can be pierced. So this is the needles, the type of the can be provided here. These are the needles of these provided to remove this one top and the operation of the motors or in the top operation of the in the top by using. So it can be lifted and the gates and can be water can be released, and unless it can be stopped by using the systems of the in the top mode operation of the gates. Next, radial gates. What is meant by radial gates? A radial gate is the gate has to be upstream face of the cylindrical, and this axis can be segment of the cylindrical form upstream face of the horizontal, and the face will be formed steel skin plate can be provided segment and hollow cylindrical supported on the steel frame. The radial gates can be advantages. The vertical gates are quite popular. So the friction of the radial gates can be concentrated. The fixed can be vertical gates. So this is the radial gates can be provided. Okay, because of the face of the radial gates of cylinder, the pressure can be normal into the face, and the resultant of the water pressure can be throughout the center, and these gates can be provided 15 meters height to 20 meters span can be provided. These are usually more economical and the vertical gates of the same size. So why? Because this is the economical, and also you can protect the lot of pressure can be due to the shape it can be. Let us see the radial gates. The radial gates can be protect and the shape can be by operating of this one, it can be lifted upwards and downwards, and also the pressure of the water can be this side can be protected due to the curve shape of this one. So it can be also to reduce the wave pressure and wind pressure can be also be should not be affected not more than that. So the structure will not be damages. That is the very important with this be provided, but it is economical when compared to the radial gate. This is operation will be also very simple. The motor which is connected here and it can be lifted up and downstream of the radial gates. So this is the drum gates. Also this is the drum shaped. The shape will be the drum shape can be provided. So this operation can be opened. It can be lifted upwards. So it can be opened simultaneously, and after this the water can be reached up to the level. It can be stopped to storage of the water. Next, vertical lift gates. Vertical lift gates. Why vertical lift gates? Vertical is rectangular gates are commonly used for spillways. A vertical lift gates consists of vertical framework fabricated of the steel members. A steel nail plates can be provided on the upstream side of the steel frame. The vertical gates can be vertically and can be plain. The grooves can be provided here. The vertical radial can be lowered. The fastening and the arrangement of the cable can be. Let us see the in the vertical gate. It can be operated by the topmost level, topmost by using the rope or any other. The grooves can be provided as I shown in the previously. It can be the gates will be provided here, and it can be moved in the upward due to the manually operated of the lift. It can be lifted the gates. The water can be released here, and again it can be closed. What happens? The water can be storage can be provided. So this is the very important of the vertical gates. Next, so these gates are usually provided in the counterweights by using the counterweights. So as you see in the counterweights in the let us see the one best example. The barrage in the Vijayawada Prakasam barrage Vijayawada is the best example for the counterweights can be provided to lifting of the gates. It can be connected in the sides with the grooves and also operating with the chains in the huge chains can be provided and a cement concrete blocks can be provided and it can be lifted and it can be done according to the requirement of the operation of the gates. Next, this is the sliding gates and the stone gates and fixed wheel gates. Next, this is the as we see in that diagram. So it can be operated in the top. It can be lifted of the gates. After lifting, what happened? It can be released the water here, and again it can be closed simultaneously. Next, bear trap gates. Bear trap is also movable drum gates. Also we call it as movable drum gate. A bear trap gates are consist of the two leaves of the steels, which is the leaf hinged into the upstream side, and the other of the downstream side the crest. The bear trap gates are suitable for the low navigation dams, and these can be widely used in the deep recess is not to be required. These guards may be designed to operate the automatically. These are the bear type of the gates. So let us see in the bear type of the gates. So you can understand it can be hinged to the upstream side. So let us see the upstream side. It can be hinged in the top and it can be opened. The drum seal of the water. It can be opened due to operating of this one, and bear trap gates can be provided. The water can be releasing, and beyond the lower lip and the upper lip, the side can be fixed this one, and it can be removed also. After that, it can be the water can be comes from the bear trap. So, a very important point is these gates are designed to operate automatically, don't need manually. So it can be operated by automatically. The motor which is connected here, sorry, it can be connected here, and it can be removed here. Automatically the gates will be opened by operating of the electrical system. So it can be open, and it can be after the water can be released, it can be stored. So if we want to storage of the water, it can be closed by. Why this is the very important, and this can be very useful for the bear trap for navigation purposes. Generally, we are using such type of the. It can be removed that one. The ships will be going inside and one side to other side, and again it can be after this it can be closed the water. So that is the bear type of the gates. Oh, so let us see. Today we have to discuss the different type of the what is meant by Ogee Spillway and types of the types of spillway and Ogee Spillway. Why we have to provide the spillway, and the different type of the spillways can be provided, and also the different type of the gates can be provided over the spillways. Different type way we have to provide the different gates, different type situations as per the design will be discussed today. So this is we are closing here. So okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.